In the today's session, we are going to deal with bridge rectifier. But before going to deal with that particular bridge rectifier, firstly we will see which are the points that we have discussed in the last session. So in the last session, we have discussed about step down center tap transformer rectifier. In that particular rectifier, it consists of the two diodes. First one is a D1 and second one is a D2. In the positive half cycle, D1 is in conduction, therefore across the load resistance we are getting the output. In same way, in the negative half cycle, diode D2 is in conduction, therefore we are getting output across the load resistance. Means in short, we will say that in the center tap transformer fluo rectifier, we are getting output in both the half cycles, that are nothing but in 0 to pi as well as pi to 2 pi. Now we will proceed towards a next type, that is nothing but full wave bridge rectifier. So this is nothing but the circuit diagram of the bridge rectifier. Firstly, we will see which are the different components are required for designing the bridge rectifier. So single phase 230 volt AC supply is required. A step down transformer, that is T1, is required. 4 diodes D1, D2, D3 and D4 are required, and one load resistor is required. So we will see what is the actual operation of the bridge rectifier. Before that, we will discuss why the name bridge rectifier, because these 4 diodes are connected to form a bridge, therefore it is known as a bridge rectifier. Then we will proceed for the positive half cycle operation and the negative half cycle operation. So operation of bridge rectifier during positive half cycle. Again, this is nothing but a circuit diagram of the positive half cycle. We will see what is the actual operation. So for our sake of simplicity, here we have considered point A and B. So in positive half cycle, we have considered point A is positive and point B is negative. Then we will see how the load current flow when A is positive and B is negative. Next, A is positive and B is negative is nothing but, firstly we are dealing with the positive half cycle. So flow of load current is from point A towards diode D1 towards load resistance. Through this particular link, it come to the D2 and again it back to the negative point. Means we will say that in the positive half cycle, diode D1 and diode D2 are in the conduction, means they are on. Diode D1 and D2 are on, means we are getting output across the load resistance in the positive half cycle due to that D1 and D2 diodes. Then next point is operation in the negative half cycle. So this is nothing but a circuit diagram for the operation in the negative half cycle. Again here, if we are dealing with negative half cycle, we have changed the polarities in such a way that here we have considered B as a positive and A as a negative. So we will see how the load current flow. So from point B, load current starts to flow. After that, through D3, again through load resistance, through this link to the point D4, and again it back to the negative. Means here a cycle will get completed. Means here we will say that diode D3 and D4 are in the conduction and diode D1 and D2 are not in the conduction, means they are in the reverse bias state. They are reverse bias, means they act as a open switch. So during negative half cycle, diode D3 and D4 are on, due to which we are getting the output across the load resistance. So after the completion of the positive half cycle and negative half cycle, we will move towards the waveforms of the bridge rectifier. So first waveform deals with the secondary voltage, that is nothing but VAB. So already we have seen in the positive half cycle, means in 0 to pi we are getting output across the load resistance with the help of diode D1 and D2. And in the next half cycle, means in the negative half cycle, means from pi to 2 pi we are getting output due to the diode D3 and D4. So we are getting complete continuous cycle from 0 to pi and pi to 2 pi in the bridge rectifier. Second waveform is nothing but load voltage waveform is there. Next is load current waveform. Here a pure resistive load is there, therefore we are getting same shape of the load voltage and load current, only there is difference in the amplitude, means load current amplitude is less as compared to load voltage because of the voltage drop takes place. Then next waveform is current through the diode D1 and D2, and last waveform current through the diode D3 and D4. Here in the 0 to pi we are getting current through D1 and D2 because in the positive half cycle diode D1 and D2 are in the conduction, and here a last waveform, that is current through the diode D3 and D4, we are getting in pi to 2 pi because in the negative half cycle diode D3 and D4 are in the conduction. Then we will just summarize all these points. During positive half cycle, means in 0 to pi, diode D1 and D2 are on, means they act as a closed switch because they are forward biased, and diode D3 and D4 are off, means they acts as a open switch, means they are in the reverse bias. So output is available across the load resistance due to the diode D1 and D2 in the positive half cycle. In same way during negative half cycle, means it deals with a pi to 2 pi. In that particular cycle diode D1 and D2 are off, means they act as an open switch, means they are in the reverse bias state, and diode D3 and D4 are on, means they act as a closed switch, means they are in the forward bias state. Output is available across the load resistance due to the diode D3 and D4. So this is nothing but a summary points of the bridge rectifier. Then we are moving towards the bridge rectifier with a filter. So here firstly we will see which are the different components are required for designing of the bridge rectifier with capacitor filter. So 230 volt AC supply is required, step down transformer is required, 4 diodes are required, a load resistance is required, and additional part is there, that is nothing but capacitor. Capacitor is here capacitor is used for the filtration purpose. What is mean by filtering in the rectifier? So filtering is nothing but removing of the ripples from the output of the rectifier. Means whatever the AC content is there in the output of rectifier, that will get removed with the help of this capacitor filter. After the operation of this particular bridge rectifier with capacitor filter, we are getting the waveforms like this. So firstly, as we have seen in the last video also, firstly we have to draw a dotted line from 0 to pi as well as from the pi to 2 pi. Why? Because we are getting output in both the half cycles. After that, this particular waveform is divided into the 4 portions that are nothing but 0 to A to B, B to C, and C to D. We will see how it actually operates. Initially, the voltage on the capacitor is considered as a 0. So next point is 0 to A portion is there. 0 to A portion is there is nothing but here in this particular 0 to A portion, our diode D1 and D2 are in the conduction. Means due to this D1 and D2 diode, our capacitor will get charged. So at point A, capacitor will get charged up to the peak value. Means here at point A, Vc becomes equal to Vm. But after point A, our D1 and D2 diodes goes into the reverse bias. Why? Because after the point A, capacitor voltage become greater than the instantaneous rectified voltage. Therefore, in the portion 0 to A, we are getting D1, D2 diodes are in on state, and from A to B, all the diodes are in off state. Why all the diodes are in off state? Because in the positive half cycle, already we have seen D3 and D4 are in off state, and after point A, D1 and D2 also goes in the off state. Therefore, in the area A to B, all the diodes are in off state. Here positive half cycle will get completed. Now we are moving towards the negative half cycle. In the negative half cycle, already we have seen diodes D3 and D4 are in the conduction. So from B to C, here again this portion indicate charging of the capacitor. At point C, again capacitor voltage become equal to the peak voltage, that is Vc becomes equal to the Vm. But after point C, this dotted line indicate that this forward bias D3 and D4 diode goes into the reverse bias. So C to D portion indicate discharging of the capacitor. Same cycle repeats itself. Advantages and disadvantages of the bridge rectifier. So we will see firstly which are the advantages. Small size transformer is required, center type of transformer is not required here. This makes bridge rectifier cost effective, rectifier efficiency is high. So what are the disadvantages? So number of diodes used are 4 instead of 2 for the full wave rectifier. Means if we are dealing with center type transformer rectifier, it consists of the 2 diodes, but if we are dealing with the bridge, then it requires the 4 diodes. Then second disadvantage is 2 diodes conduct simultaneously, due to which a voltage drop increases and output voltage decreases, or we will say that output voltage reduces. Thank you.